Okay, part A. Check the NDCQ is satisfied. So, part A. So we do the usual thing, case 1. So suppose you have only one constraint is binding. If only one constraint is binding, then we have three choices here, either this one, or this one. So we write down each of their Jacobian matrix. So if minus x squared minus y squared equals to minus 1, then the Jacobian matrix equals to, in this case, equals to minus 2x minus 2y. But then you realize that this cannot be the zero matrix because of this constraint. Okay, now this constraint is binding, so it's impossible for x and y to be both 0. So that means that it has rank 1. Okay, and then if this time is x equals 0, so it's the second constraint that's binding, then the Jacobian matrix equals to 1, 0, and obviously 1, 0 has rank 1, so that's okay. And finally, the last case is if y is 0, so in this it means the last constraint is binding, then the Jacobian matrix equal to 0, 1, and that also has rank 1. So in all these cases where only one constraint is binding, then the rank equals to the number of binding constraints, so NDCQ is okay. Now you have case 2, where only two constraints are binding. Then you have three possibilities. Either the first two are binding, so either the first two are binding. But then that would imply what? That would imply y equals to 1. Okay? So the Jacobian matrix in this case equals to minus 2x minus 2y and then 1, 0. But we know that in this case, when these two constraints are binding, then x is 0, y is 1. So be careful, y cannot be minus 1. Rejected. Because y is non-negative, okay? Because y is non-negative. So, when x is 0, y is 1, then we get 0 minus 2, 1, 0. This has rank 2. So in this case, NDCQ is satisfied. And then now we try similarly the other two possibility. So if it's the first constraint and the third constraint that are binding, then in this case x equal 1. So the Jacobian matrix, let me say Jacobian matrix, equal minus 2x minus 2y, 0, 1. Okay, and then that equals to, when x is 1, y is 0, you get minus 2, 0, 0, 1. So x is 1, y is 0. So this also has rank 2. And finally, if it's the last two constraints that is binding, x equals 0, y equals 0, then the Jacobian matrix, the rows will be formed by the gradient of the constraint function, and then so these two rows, so 1, 0, 0, 1. And then of course this identity matrix, so it must have rank 2. Okay, so in all possible cases, well, maybe I should add case 3, all constraints are binding. All constraints are binding. But then it's easy to check. In this case, it's impossible. So check. This is impossible. Okay? So what can we conclude? We conclude that in all cases, the Jacobian matrix has full rank, therefore the NDCQ is satisfied. So in all cases, in all possible cases, the Jacobian matrix has full rank. So therefore, the NDCQ is satisfied. So we're done. Okay.